Okay, my name is Hans Hartmann. I was the coordinator of a European project which was involving Austrian, German and Danish and also Swedish partners, where we wanted to improve stove performance. The name of the project was Wood Stoves 2020, and our approach was to not only look at the stove itself, but also to look at the environment where the stove is put into. How will the stove perform? There are many ways of doing that. One way is, of course, to improve the geometry of a stove. Means that the shape of the stove, the way the air is directed to primary and secondary air uses, and all this geometry can be optimized by a computational fluidized dynamics, which is an interesting new technique to optimize the stove before you test it. That is done in a simulation. You can simulate the combustion behavior before you build the stove, and by doing that you can introduce certain changes without needing to build it and to test the effect of those changes. That was a very successful part of this project, and it yielded in very let's say advanced geometries of stoves. But of course, beyond the stove geometry, you have to decide how will the air insertion or the air distribution to primary and secondary areas will be performed. And that is another part of this project, where we wanted to improve the air control. That means to introduce sensors that determine the stage in which the stove is at the moment, and then decide how much air is directed to the grate, how much air is directed to the window perch air, and how much air is directed into the tertiary air nozzles. And that is a very dynamic process. It needs a proper sensor. We have been testing quite a few sensors also that were found useful for such an automatic control. There are simple control strategies. One is with only temperature sensors, which are built into the combustion chamber. Better not, that was the result, better not put it at the end at the socket of the flue gas. Better have it in the combustion air, in the combustion chamber, where you have more dynamic processes. And the other was another oxygen sensor that is combined with the temperature sensor, that gives a more sensitive information about the stage where the stove is in. And with those sensors and a proper strategy of when to open and to shut down the air flaps, very large improvements of the stove performance have been achieved. The next issue of the project was also to look at catalyst. Catalyst can be built either somewhere in the connection pipe to the chimney, but there it is very ineffective. As we found, it should be actually in the outlet of the combustion chamber. Catalysts that can transform CO, carbon monoxide, also organic volatile carbons, into some, let's say, CO or non-harmful substances, flue gas substances. That was quite interesting what we found, and also reduction rates of like 70% for CO could be found, and for OGC maybe like 20 to 30. But it was also concluded that better improve the stove in the geometry and also in terms of air strategy before you step into this catalyst program, and before you decide to introduce a catalyst, which is only an ultimate measure after all improvements have already been made. And finally, I would also like to say that by not shutting down air supply at the end when the stove is cooling down, we have discovered that very high temperature, or let's say heat losses, can occur, which you don't want just to let escape from the living room where you have your stove built in. And by a shutdown of air flaps, which is also done automatically in a preferred way, you can prevent, let's say, like around 10 to 12% of the wood fuel to be used inefficiently. If you have, for example, 3 batches of wood that you apply in a wood stove, then at the end you can save like 10 to 12% by shutting down the air valves at the end of the combustion, which is usually not done, unfortunately, but with an automatic control or just simple air flap at the inlet of the combustion air to the stove, you can prevent those losses. That was also a strong argument in favor of automatic air controls.